Hi. In this video, we are going to look at some problems in geometry and we are going to apply Cartesian coordinates methods or coordinate geometry methods to solve them. So basically, sometimes there are tricky problems in geometry where if you set up the coordinates properly and you write the equations of your lines and circles and all, you can approach those problems using coordinate geometry. The solution is usually longer, but it is more reliable and it's easier to find. So what we'll look at is a few problems that will get us up to speed with this technique, and we'll learn how to apply analytic methods in plane geometry. So we'll start off with this one. Question 1 says, extend the two sides AB and AC of triangle ABC to D and E such that mod of BD is equal to CE. Suppose that the midpoints of BC and DE are M and N respectively. And AT is the angular bisector of angle A. Angle bisector of angle A. We have to prove that MN is parallel to AT. So let's think about this question. We have a triangle, AB and AC sides have to be extended to D and E such that BD is equal to CE. Okay, so fine. And midpoints of BC and DE are connected. M and N are connected. And we have to draw an angle bisector of angle A and finally prove that MN is parallel to AT, right? So let's think about the figure. Usually you would draw a triangle like this with A on top, but we have to construct an angle bisector here, T, right? So this figure is also possible where you extend B to D and C to E and BD is equal to CE. That is given. Midpoint of BC and midpoint of DE are connected. So midpoint of DE might be somewhere here. You have to prove that this MN is parallel to AT, right? So this figure is fine, but we'll want to work with a slightly different figure here. So let's draw A here like this and B somewhat like this. And similarly, C here like this, right? Now, the reason why we are choosing it like this will become apparent soon. So this is my triangle ABC and we extend B to D and we extend C to E. And it is given that CE is equal to BD. Okay. And midpoint of DE and all. So we have to join DE first. Let's join DE like this. Midpoint of BC is M and midpoint of AD is N, right? So we connect this. This is my MN line. And let's say we have another line here, which is angle bisector. Let's say this is my T line, AT line. I have to prove that MN is parallel to AT. This is the midpoint. This is also a midpoint. M and N are midpoints. I have to prove that MN is parallel to AT. Now, we know because AT is an angle bisector, lines AB and AC are symmetrical about the bisector, about AT, right? So if they are symmetrical about the bisector, we have to choose our coordinate system in this question. So this angle is equal to this angle. So it will be convenient if we choose our A as the origin, right? Let's choose A as the origin, and this becomes our y-axis, and AT, which is the bisector, becomes our x-axis. Why is this good? Because if the bisector is the x-axis, then the slope of the line AB and the slope of the line AC are equal, but just have the opposite sign, right? Because this angle theta and this angle theta are same. So line AB will have slope some tan theta, and for slope for AC will be minus tan theta, correct? So we are going to say this angle is theta. Therefore, if we say this side, AB side has length small c and AC side has length small b, we know c is the distance and theta is the angle. So using polar coordinates, we can say that the coordinates of B point has coordinates c cos theta, c sin theta. And similarly, C point has coordinate, this is minus theta. So it will become B cos theta and minus B sin theta, right? So we have set up our coordinates in such a way that B and C are coming very easily, right? Now let the distance BD, which is equal to the distance CE, be called T, right? So the overall length of A to D will become basically C plus T, and the overall length of A to E will become B plus T, right? And they are on the same line. So the coordinates of D and E are also coming very easy, right? Coordinates of D will become C plus T cos theta, comma C plus T sin theta, whereas coordinates for E will come out as B plus T cos theta and B plus T minus sin theta. So it is pretty simple using our correct choice of XY axis and origin to basically figure out the coordinates of all of these points. A is 0, 0, B and C and D and E we have found, right? So now what we can say for sure here is y coordinate of M, which is the midpoint of BC, will be equal to YB plus YC by 2, which if you calculate what is YB plus YC by 2, YB is C sin theta, YC is this, so it is basically C minus B by 2 sin theta, right? Similarly, y coordinate of N is what? It is the midpoint of D and E. So take the y coordinates of D and E and add and divide by 2, right? So if you do that, you will notice that T sin theta gets cancelled, and that is also C minus B by 2 sin theta. So obviously the y coordinates ym is equal to yn. So equation of line Mn will be something like, or actually we can see that it's a horizontal line. The level y values of both the coordinates are same. So we don't even need to write the equation. Slope of Mn is 0. And if slope of Mn is 0, we know that slope of AT was 0 because we chose AT as the x-axis, right? Since we have chosen AT as the x-axis, we are getting slope of AT is 0 and slope of Mn is 0. So that implies that Mn is parallel to AT. So a very simple solution based on choosing the right xy coordinates and the right origin. We chose A as the origin and xy coordinates as AT as the x-axis, right? And that was the trick to solving this problem. Let's look at another one. Question number 2. The tangent points of the inscribed circle of equilateral triangle ABC with the three sides are D, E, and F. D, E, F. If the distances of any point P on arc EF to the three sides are P, Q, R respectively, we have to prove that root of P plus root of R is equal to root of Q. Okay, so let's look at this question. We have to draw an equilateral triangle here. And in this triangle, we have to draw our inscribed circle. Let's say this is my inscribed circle here. This is A, B, C, and these points can be labeled as D, E, and F. So there is a random point on the arc EF. So this is my point P, and I have to find the distances of P to each of the sides. So I am dropping perpendiculars from P to the sides. So these distances are given to be small p, small q, and small r, right? So these distances are p, q, and r. And what I have to prove is root p plus root r is equal to root q, right? Now, again, in this problem also, setting up the coordinate system and choosing our origin is the crucial part. So in equilateral triangles, it is best to usually choose the origin as the centroid. So we will set up the coordinate system, set up the xy axis with center of inscribed circle, which is basically the centroid, center of inscribed circle or circumcenter, which is the centroid also, as the origin. So if the center of the inscribed circle is origin, and let's assign, without loss of generality, we can say the radius of the inscribed circle to be equal to 1, right? So if we have set the radius of the inscribed circle to be 1, we know that this distance is 1 and this distance is 1 and so on, right? Now, using the normal form of the line equation, what was the normal form? So first we set up our x-axis like this and y-axis like this. So we know that this angle will be equal to, we have this angle is clearly, this is 60, so this is 60, so this 90, so this is 30 degrees, right? So this perpendicular has length 1 and angle is 30 degrees. So equation of AC should be what? X cos pi by 6 plus y sin pi by 6 equal to 1. And similarly, equation of AB will come out to be what? X cos, now AB would be this line. So the angle here from the center here, this total angle is 30, basically 30 is here. So it is 150 degrees. So 5 pi by 6, x cos 5 pi by 6 plus y sin 5 pi by 6 equal to 1. And similarly, BC side, using the normal form of straight line, will become x cos 3 pi by 2 plus y sin 3 pi by 2 is equal to 1, right? These are the equations of the three sides that we are getting if we choose the origin as the point which is the circumcenter of the triangle or the center of the inscribed circle. Now, P is a random point on this circle. So P's coordinates can be given as 1 cos theta, 1 sin theta, because the radius of the circle is 1. So cos theta sin theta is our P point. And now it is very easy to find the distances root P, root Q, and root R from point P, which is this point, to each of those straight lines. We know the equations of the straight lines, so it is quite easy to check this distance. So for example, root R is basically going to be distance of P to the side AC, right? So P point was cos theta sin theta, and side AC equation was x cos pi by 6 plus y sin pi by 6 equal to 1. So by using distance to a line formula, you will get mod of cos theta cos pi by 6 plus sin theta sin pi by 6 minus 1 divided by root over this square plus this square, which is 1. So the distance here is r should be equal to this. So root r should be equal to power half of this. So if you simplify this a little bit, we are getting root r is equal to 1 minus cos of theta minus pi by 6, right? Or which can be further simplified as using the 2 sine square theta by 2 formula, you can write it as root 2 sine of theta by 2 minus pi by 12. So this r or root r is the distance from P to AC. Similarly, exactly following the same process, we know the equations of the three sides of a triangle. So we can find root P also, and you can check the calculations. Root P comes out to be root 2 sine 5 pi by 12 minus theta by 2. And similarly, you can find root Q also, which comes out to be root 2 sine 3 pi by 4 minus theta by 2. So once we have these three, it is trivial to prove that root P plus root R is equal to root 2 sine of 5 sine of theta by 2 minus pi by 12 plus sine of 5 pi by 12 minus theta by 2. If you simplify this, it becomes 2 root 2 sine of pi by 6 and cos of theta by 2 minus pi by 4. And sine pi by 6 is half. So therefore, root P plus root R is coming out to be root 2 sine root 2 sine 3 pi by 4 minus theta by 2. This is what it will come out to be. So that is actually equal to root Q. Basically, it's very simple. It is distance formula from a point. The point is cos theta sin theta. The line equations can be easily found out. And then you can prove the problem. You can prove the statement of the problem. Let's look at another one. Question number 3. In a circle O, a chord CD is parallel to another chord EF, and intersects a diameter AB, in with angle 45 degree, angle of 45 degree. If CD and EF intersect the diameter AB, at P and Q respectively, and radius of circle is 1. Radius of circle O is 1. We have to show that mod of PD multiplied by mod of QF plus mod of PC multiplied by mod of QE is less than 2. This is what we have to prove. So let's first draw the figure. This is a circle. We have a chord EF which is parallel to chord CD is parallel to another chord EF. Okay. So we draw one chord CD here and one chord EF here. These are parallel chords. The circle center is here, and we can make a diameter like this. And the diameter is AB, so let's call this point as A, and let's call this point as B. And it cuts the chord at an angle 45 degree. So intersects a diameter at an angle 45 degree. So since they are parallel, both these angles are 45 degree, right? and center of the circle is O, and we have been given that CD and EF intersect at P. So this point is P and this point is Q. Right. Radius of the circle is 1. So we have this situation. It is obvious that we should make a line parallel to CD and EF, straight line parallel to CD and EF that can be passing through O, passing through O. That line is our x-axis. So this is my y-axis, which is perpendicular to both CD and EF, and this is my x-axis, right? Equation of the circle, the origin of the circle, the origin of our xy plane is at the center of the circle. So circle equation is simple. It is x square plus y square equal to 1, right? Now we can say let the distance between CD and the x-axis be A. So what we are saying is, let's say this distance is A and let's say this distance is B, right? The distance between CD and x-axis is A, and distance between EF and x-axis is B. What is the benefit of assuming these two things? Because if you know A here, we basically know the height of this point P, right? So y coordinate of P is A, the angle is 45 degree. So you can say that tan 45 is 1. So y by x is 1. So this is also A. So the coordinates of P are A comma A. And similarly, if this is 45 degree, this distance is B. So this is also B. The coordinates of Q are minus B comma B, minus B, right? Minus B comma minus B because Q is in the third quadrant and P is in the first quadrant. So if you know the coordinates of P, basically now you can find the coordinates of C and all. How? We know that the y coordinate of C will be A because we had made the line parallel to CD. The line parallel to CD is x-axis, so CD is also a horizontal, perfectly horizontal line. So the coordinate of C, D, E, F can now be found. So what we have is this situation: C, D, E, F, circle, diameter A, B, and this point was P, and this point was Q. And we know P is A comma A, and Q is minus B comma B, and this is O, which is 0 comma 0. This is my x-axis, this is my y-axis. So it is obvious from here that coordinates of C and D will basically be points lying on the circle, but y is equal to A. So therefore x can be plus or minus root over 1 minus a square. So C coordinate will be minus of root over 1 minus a square comma A, and D coordinates will be plus of root over 1 minus a square comma A. And similarly, you can find E coordinates will be minus of root over 1 minus b square minus b, and F coordinates would be root over 1 minus b square and minus b. So now that we have C, D, E, F, we can directly find the distances. Distance of PC would be what? It is simply A minus the x coordinate of this. So it is A plus root over 1 minus a square. Distance of PD is equal to root over 1 minus a square minus a. Distance of QE is equal to root over 1 minus b square minus b, and distance QF is equal to root over 1 minus b square plus b. Now you can prove the inequality that we had to establish. So what is that we had to find out? PC times QE plus PD times QF. So PC times QE, if you see, will be 2 times. Okay, we'll just calculate it out. we a root over 1 minus b square minus ab plus root over 1 minus a square 1 minus b square minus b root over 1 minus a square and plus pd into qf. So that should we give you plus root over 1 minus a square 1 minus b square minus a times root over 1 minus b square minus b times or plus b times root over 1 minus a square and a minus ab, right? So notice that this term gets cancelled with this and this term gets cancelled with this. So you are ending up with this result PCQE plus PDQF is equal to twice of root over 1 minus a square 1 minus b square minus ab, right? Now by AMGM this is less than equal to, this root is less than equal to 1 minus a square plus 1 minus b square by 2 minus ab. Here we are using AMGM inequality on this radical terms, right? So if you simplify this, this becomes 2 minus a plus b whole square by 2 multiplied by 2. So that is equal to 2 minus a plus b whole square. And since a plus b whole square will always be positive, this is less than 2. So that was what we wanted to prove. It is not possible for a to be equal to b. Since it is not possible for a to be equal to b, here in this question, we have a strict inequality less than 2, right? Okay. We look at one final problem. Again, the choice of coordinates will become crucial. So pay attention. A quadrilateral ABCD is circumscribed to a circle O. Let the foot of the perpendicular from O, let foot of perpendicular from O to diagonal BD BM. We have to prove that BD bisects angle AMC. So let's draw the quadrilateral first. Some random type of quadrilateral we are drawing. This is A, this is B, this is C, this is D. And then there is a circle that circumscribes or inscribes all of the sides, right? The quadrilateral is circumscribed to this circle. Okay. Now, foot of the perpendicular from this circle has center O, somewhere here. Foot of the perpendicular from O to the diagonal BD. So diagonal BD is somewhat like this. Diagonal BD will be like this. And foot of the perpendicular from here is our point M. This is our point M. This is the perpendicular from the circle center to the diagonal, right? So we can say that correct. We'll set up a coordinate system with BD as the y-axis and M as the origin. Now this figure doesn't look appropriate. What we'll say is this is my BD, BD, and this is my A, B, C, and D, let's say. And then A and C. Now you can say that BD diagonal, foot of the perpendicular from the origin. This is my origin, and this becomes x-axis because this angle is 90. This becomes my x-axis, this becomes my y-axis, right? Now we have selected our M, which is the midpoint, which is the foot of the perpendicular, that is our origin, 0, comma 0, right? So what we can say is coordinates of the or coordinates of O, this point, coordinates of O will be some t comma 0, right? Where t is the perpendicular distance from the origin to the diagonal. So without loss of generality, we will assume that radius of this circle is equal to 1. Okay. So what we can say now is that we can write D and B pretty easily because we know that that is my y-axis. So D can be written as 0 comma D and B can be written as 0 comma minus B, right? Where both B and D are greater than 0. So this is my D point and this is my B point. And what do we need to show that BD bisects angle AMC? To show BD bisects angle AMC, what we need to show is that slope of AM, slope of AM is equal to and negative in sign with slope of MC, right? So AM and MC are these points, are these line segments. So if the slope of these two is same, what you can say is that BD is bisecting the angle AMC, right? In that case, correct. Only if BD bisects angle AMC will the slope of AM and MC be same. So now what we'll do is we'll apply coordinate geometry a little bit. We'll say let the slope of line 2D and tangent to circle O be this equation. We'll write it like this: y is equal to kx plus d. Why is it kx plus d? Because it passes through the point D. The point D was 0 comma D. K is the slope of my line, right? From D, passing through D and tangent to the circle. Now, since distance of origin to this line is equal to 1. Why? Because 1 was the radius. So distance from the origin to the point to that line is definitely 1. So therefore, if you apply this condition here, 1 should be equal to 0 minus t mod root over 1 plus k square, right? So from here, distance from origin to this line is 1. Okay. So uh, we had said the tangent to the circle is this equation. So distance from center of the circle to this line equation is 1. So from there, we should get this relation. Okay? We should get wait, I have made a mistake. The origin was not 0, 0. Here in this problem, if you remember, the diagram was like this. PD was this line. Right. So what mistake I was making here was the fact that when we drew the quadrilateral, when we set up our origin, we had said this BD line is the y-axis, right? And we had said that the M point was the origin. What was M? It was the foot of the perpendicular from O to this line, right? M point was our origin. So if you say the distance of O from M is t, then the coordinate of O becomes t comma 0, right? The coordinate of O, which was the center of the circle, is actually t comma 0 in this case, right? So then the distance from O to this line must be equal to, using t comma 0 as our O, it will become tk plus d mod by root over 1 plus k square, and that is equal to 1, right? So from here we get k square plus 1 is equal to tk plus d whole square. So simplifying this equation a little bit, we get k should satisfy 1 minus t square multiplied by k square minus 2t dk plus 1 minus d square is equal to 0. Now, since dA and DC are tangent to O, the slope of dA and DC, the slopes of dA and DC are the roots of this equation. Roots of this equation. Because if you remember, our straight line was y is equal to kx plus d, which was the slope of the straight line through D and tangent to the circle O, right? So k was the slope of that straight line. So this quadratic equation should give us slopes of dA and DC, right? So kdA and kdC are roots of this quadratic, right? So what we get is kdA plus kdc is equal to sum of the roots in this quadratic is 2td by 1 minus t square. And now we can make a similar quadratic for the other two sides also, BA and BC. Why? Because we can just substitute minus b for d. Substituting minus b for d in this, because the other two sides are similar. So we will get this quadratic for them. 1 minus t square k square plus 2tbk plus 1 minus b square is equal to 0. And the slopes of BA and BC are roots of this. So from there we get KBA plus KBC is equal to minus 2TB by 1 minus T square, right? Also, our two line equations were what? Our two line equations are like this. Y is equal to KDAX plus D. That is the line equation for dA. Y is equal to KDAX plus D is the line equation for dA. And y is equal to KBAX minus B is the line equation for the other side. If you solve this, this is the line equation for BA, line equation for DA. If you solve these two line equations, you should solve for the coordinates of A. And if you do that, you will realize that A's coordinates are coming out to be B plus D by KBA minus KDA, comma, B times KDA plus D times KBA by KBA minus KDA. This is coming as the coordinates of A, and from here we can say that the slope of AM is equal to YA by XA, which is basically BKDA plus DKBA by B plus D. And similarly, you can find the slope of MC. Slope of MC would come out to be BKDC plus DKBC by B plus D. Once we have these two slopes, you can now prove that slope of KMA plus KMC is equal to 0. You can just prove that because we know the values of KDA plus DC plus KBA plus BC, right? So since these two slopes come out to be adding up to 0, that means that MA and MC are symmetrical with respect to BD. So we can therefore show that MA and MC lines are being bisected by this BD side. So again, quick recap here. We had a quadrilateral. This is circumscribed to a circle with center O. There was a circle with center O. BD was a diagonal, right? Perpendicular from O to BD was called M. And we said that this is our origin, O 0, 0, right? We have to prove that BD bisects AMC, right? So to prove that BD bisects AMC, that is why we took this as the y-axis. Take this as the y-axis, take this as the x-axis, and origin is now becoming t comma 0, right? And I want to eventually show that AM and MC, these two sides are being bisected. The angle here is equal to angle here. So how do I show that? I have to show that slope of AM is equal to negative of slope of MC, right? Because then only this angle and this angle will be matching, right? So that is easy to show with our choice. So what we started off here was we just wrote the coordinates. So we wrote D as 0 comma D and we wrote B as 0 comma minus P, and we need to show basically slope of AM is equal to negative of slope of MC to prove the problem, right? So equation of the this circle equation we took as x square plus y square is equal to 1, assuming that the circle radius is 1. And equation of straight line through D, this point, would be y minus d is equal to k times x minus 0. So y is equal to kx plus d. And this line is basically tangent to the circle. So therefore, distance from the circle to this line should be 1, right? K is the slope of this line dA, right? And similarly, DC is also a similar line. So when you took the distance formula from t comma 0 to this line, what we got is a quadratic in terms of k, from where we concluded kdA plus kdc value. Doing a similar calculation, we can find kba plus kbc value. Once you know these two things, all you need to find is slope of AM and slope of AC, right? How do we find A and C points? That is simple. Take this line equation and take this line equation and solve these two line equations for coordinate of A, right? It will come in terms of B and D and the slopes, right? So try it yourself. I think you should get the hang of it. The main thing in the question was choosing the correct y-axis and the correct origin. If you choose origin as M, the question is easy because you just have to get the slopes of AM and MC, right? So that's about it for geometry techniques, geometry questions being solved by analytic methods. So try and apply this coordinate geometry techniques to some geometry problems. You might get success there. And we will continue in the next class with a new section that will be about proof methods. And we'll start off with proof by contradiction. We'll look at proof by contradiction and the construction method. And these two methods will be the subject of the next two videos. I'll see you next time.